Heyo, who's all here today? I wore a green shirt. Not the best for streaming with a green screen. But if you're in the chat, feel free to say hi. I'm looking over here at different messages. I like it. People are sending out a bunch of nice messages to each other. Happy Wednesday, day before Halloween. And just getting everything organized on my screens. We'll get Mewbot awake. So Mewbot is now waking up. So let's see. Get everything organized. Try a little chill music here. I don't know if anyone's here yet. Can't hear the music anymore though. Can't hear the music. Still, I think I'm holding in-person office hours today. Doing better, recovering. Doing better. Talking to myself, so. Doing better though. Looking through a lot of emails last night. Very busy night with Stats 1 test. Oh, homecoming. UT has a contest each year. Person's got homecoming team show. Winning team judging is 67. Gets good. What are we gonna decorate? What do we decorate? It's the 5th. That's interesting. It's a Tuesday. Wait, I'm teaching. Am I teaching then? Am I teaching? It's so quiet in here. I might do that. Okay, good. Charlie replied to this one. It's doing work. We could do some work right here. We'll see if anyone joins up. But we could talk about what we'll be doing in Tool 1. I have a message here. Oh, there we go. Okay. Okay, so much credit being funny. There's some points. So much credit. Oh, which one is doing this? Okay, there we go. I have to fix the My Pearson. My Pearson has had issues with doing work a little bit late. So I'm going to go in and fix the My Pearson here. Might need to fix it at the end of the semester. There's so many, like My Pearson's just being hugely troublesome. They changed the way it integrates into Canvas with late penalties, and because of that, we have to do some adjustment on dates to remove late penalties, and there's like no real quick way to fix it. It might even change how we have to deliver it because it's just been a painful thing. It's been bad. And yeah. I think I'm all right-ish. My cough is less than yesterday. Doing all right-ish. You join in. How are you doing? I'm just sitting here doing work today. Sitting here doing work right now, getting some work done. Replying to emails. This is what it looks like when Brian does office hours at home and he's like, oh, gotta reply to this. Okay, we'll work on this. Let's get this fixed up. And so we just kind of work through and get things done. Everyone's all tired, I think. Everyone's all tired from tests yesterday, probably test fatigue. It's all right. I got it too. It was a busy night. Busy night of test. And let's see, I was wondering how the grades on the quizzes went. How did the grades on the quizzes go? Pulling those up right now. Sampling distribution for the sample means isn't that bad, actually. Noel, good morning. Good to see you. We're throwing out some Mewbot points. If you have questions, let me know. So looking at grades, like the sampling distributions, people get more stuck on, and it's tougher. You're scared? Don't be scared. The best thing to do is to do everything in the class, to do all the homeworks, all the quizzes, all the campus content, all the data analytics, all the projects. And the worst thing that has really happened to all the students who do everything is they make a B in the class. That's the worst thing that happens. And I know not everyone wants to make a B, but always have this sigh of relief that if you're doing everything, it's very hard to make a C. You go into this like B range where if the tests go well, you make an A, and if they don't go so well, you make a B, and if they go super bad, you make a C. That's kind of what I would say to all students, is that if you do all the work and you do pretty good on the tests, like 75 or higher, 75, 80s, then you can make an A in the class. If you make 75 through 650s, 75 through 50, you make a B in the class. You make lower than 50s, you make a C in the class. And it's really hard to make lower than 50s on the tests if you're doing all the work, because you'll generally have some knowledge, you'll generally do pretty well. So don't worry, the test grades will come out probably in a few days, up to a week, but hopefully a few days. I've already graded some. They're looking pretty all right. A lot of people, I would be okay with a B. Yeah, I bet you if you want, ever message me about grades and say how am I doing. I won't make projections about your individual grades here, since it's FERPA protected, but my guess would be that you, like, I'm not saying like you because I have any specifics, but generally the people who are engaged, if you're engaged, are going to fall into this, they'll make at least a B. That's just a general idea of people who are generally engaged. It's rare that they make C's, and a lot of them make A's if they do well on the test. So if you're engaged, you'll usually, and I can't promise, because it's gonna be like, if you do all the work, you make a B in the class. It doesn't work that way. It doesn't work. If you do all the work, you make a B in the class, but it's hard to not make a B a lot of times. You really have to have very bad tests, and very bad means like 50s and 40s usually. So whatever happens, just keep working, because I swear some people just give up after test 1 and test 2. They're like, whatever, and then they go to test 3 and they make like a 20, and then they're like, well, I didn't understand any of that, and then they make a C. So because they'll get to like MyLab part 3, we could, you know what we could do? We could actually do some of the new MyLab. Do you want to do a little of the new MyLab? We could knock out one of the new MyLabs here, be a little productive, and knock out chapter 14, or it's 13, confidence intervals. And you'll see there's some similarity here. So I'd say don't be worried. Keep doing the work. Remember, as Brian said, if you're doing the work, it's very hard not to make a B, at least a B. It's very hard not to make at least a B. I've had people who didn't believe me. Oh, there you go. Oh, don't worry, Kenai. It's no, I think sometimes people are too afraid or too fearful on themselves. Like, Kenai, do you want to do some work? Who wants to do some work? If you say me. The average right now on the test, before we've graded the 12 points, is a 67. With the 12 points, it could go as high as 79, but I've already graded a few, and some people said things like R squared is correlation, or the correlation, and I was like, no. You're welcome. Yeah, it's a tougher class. Stats is like, a lot of people hate stats. So the average on the test will probably be in the mid 70s. Typical average, mid 70s. Test 1 has like low 80s. Test 2, mid 70s. Test 3 sometimes goes up. Test 3 is like mid 70s, high 70s. So, you know, like test 1's a low B, test 3 is a mid C, test 2 and 3 are mid C's usually. So, I mean, that's what you usually see on tests, is a C understanding, C grades. But we want A's. I want A's. I had one semester where students made above a 90 on test 1 average, and we played We Are the Champions. I come into class and we were all like, whoa! And then they made the lowest grades on test 2 I've ever seen. They made like a 60 average. It was like so bad. I think because they got so like, this class is easy, I don't need to do anything. And I just remember being like, what in the world? And this semester is tracking like a normal semester, which I don't want. I want it to be better. I want every semester to be better. And then I'm like, how do I make it better? And the thing I see, and this is just Brian ranting for a moment, is, and we see it in class now, you probably notice it, is that attendance goes down to where we start with almost 300, and then we go to the 200, and then we're hovering around 200, then we go to like 160, 170, and we're getting half the people to come to class, and then half the people come to class are responding, because we have like maybe 90 people respond to the polls, which means half of them are away from the computer and not paying attention. It's tough. I understand. Online education is its own thing, but my goal with it is always to pull people in, to give something exciting. And it's just tough, because when I think about it, what is tough for me as an educator is if I don't have you in class, I can't even say things to help you. If I don't have your attention, I can't say things to help you. And so this is my positive energy I'm trying to bring out is, if you can, and if you hear this, go to class. If you're in an in-person class or an online class, go to your class. Because every time I'm thinking, how do I, it's a lot. Yeah, it's not just our class. This is a thing as semesters go on. And you know what, when I was a student, I stayed in my dorm room, played a little Grand Theft Auto Vice City. I actually took a vacation in Vice City, my friends said. They said, Brian went to Vice City for the semester, and I didn't do that well that semester. So sometimes I talk from experience. It's not kids these days not going to class. It's, man, I did the same thing, and I shouldn't have. Should have went to class. And I'll always try to, did you notice anything on the test last night? We won't be too specific because some people that's what my econ class is. I also might be a part of that. Gita. Let's say some points for that. It happens, right? It happens. So once again, we're not trying to talk bad about anybody, but from an educator, please come to our classes. We want to help you learn. We want to put the information out there. This is me sending a message to past Brian. Please come to class. Please. And we'll get serious here and do some work now. So I think because that's what we want. We've legal restrictions here, so I have to tell it. Oh, really? Dee Dee's over in Germany there. You have legal restrictions? If you want to expand on that, I don't know, maybe we need to do that over here in America. Going down here in Tennessee, gonna do some legal restrictions, gotta attend our class. I don't know how to talk like, am I talking like, I don't know. I've been here a while. Is it happening? Am I getting a Tennessee accent? I don't know. It's all I'm not on Dayquil today. This is, I'm just gonna knock over things. This is, I look to be recovering. So worst on Monday, worst Monday, and I took like Dayquil like 3 or 4 times. You can only take it 4 times. 300 milliliters, whatever it was. Okay, let's do some conference rules. Yeah, but I don't know. Sometimes there's this thing where I feel like I talk too much in classes. No, it's a lot of people feel that way. Yeah, but that means you're probably one of the few people learning. No, don't do that. Don't do that. Don't worry if people think you're the person who talks. That's the person who remembers things. That's the person who the professors remember. If you're professors, but I don't even think a professor should ever tell a student they talk too much. Professors want students to talk. We want you to engage. And because learning is active. It's like if you talk to your parents and they just talk to you and you just stand there, they'll just say, are you going to say something? And so we as educators want you to talk with us. And I realize sometimes classes, you're the only person talking. I've seen that. And we should always be proud of the people who are talking. We should always be like, oh, that person knows the answers. Or is trying to figure out the answers. You're paying for the learning, so engage in it. And I don't think anyone should be shamed for engaging in learning. Now, it'd be different if you raise your hand, you're like, me, and other people have their hand raised, then that's trying to hog the learning. But if no one raises their hand, I mean, I tell you, educators are like, anyone know the answer? Anybody? And then we looked at a student who raises their hand, and we're like, and they're like, I don't want to raise my hand. It's last thing, I've maybe mentioned this student before. I had a student who always knew the answers, and he was so smart. And he kind of gave himself a hard time because he was older. I've told the story already once or twice this semester, but he told me it was just harder being an older student. I wouldn't try to put him on the spot. I just glance to the back of the class sometimes. And I just look around, and I would glance, and Stuart, no last name, right? Didn't even say it. He would smile, and I would smile. And then he'd raise his hand. He'd say the answer. And I was always so proud of him, and I hope he's doing well. But we can be too hard on ourselves a lot of times. And he was really smart. He's a great guy, and I hope he's doing well. And that's all I wish for my students, just doing well. Anyways, let's do a little chapter 14 confidence intervals. Let's do it. Here we go. Thank you so much, Dee Dee. Got a lot of good memories of teaching, and that's what I rely on when I feel a little bit down, like, oh, people aren't coming to class and people aren't doing work. It happens. It's that's education. It's the way education goes. Are you new to this, Brian? Chapter 14 or 13, confidence intervals, homework, confidence intervals for the proportion. You mentioned we can't talk about that. Yep. There are some people who have either accommodations or had problems. We're finishing up all the test taking. As you know, via the announcements, I say, if you have a problem, contact me immediately. And there were people who contacted me immediately. We tried to get things working. I had like 12 people who contacted me, maybe 12 to 15. It was a handful. And I was working with them constantly. Like if any of them were to tell you, they'd be like, Brian was emailing me back within like a minute. I literally had my computer with me the whole time. And was like, the whole time the test was going, I was looking at my computer and responding to emails. And if someone said I had a problem, I was emailing them back immediately. And they were emailing me back. And most of them, we got it fixed up. but then a few had to have it moved because we couldn't get it fixed. But it was documented and it was a real problem, and that's how it works. Yeah, no, that was the slot machine ones. We can definitely do those. Those are tricky. So this deals with confidence intervals, which is relevant to next week. So next week is the election in the United States, and this question deals with confidence intervals. Pew Research in 2018 polled a random sample of 1,058 U.S. teens, and about 45% said they went online several times daily. 95% confidence interval estimates this to be between 42 to 48%. The reason I mention elections is because with polls, if you go to 538, you can see what a confidence interval looks like. So 538 used to be run by Nate Silver. And here's 538. Here's their election forecast. This is just what the simulations show right now, as we know it's very close to the election. And what I like to do is go down to the following, and you can see confidence intervals. And there is 95%. They're literally making 95% confidence intervals. As it gets closer to the day of the election, the intervals get tighter, but the thing about these intervals is they have such huge overlap. This is current. Yes, this is 538. Previously run by Nate Silver. He now has the Silver Bulletin. And these are the kinds of things when I look at statistics. They use statistical methods, and they also use simulations. We talked about simulations. So these are simulated results here with what could happen. It doesn't mean that like the probabilities relate to out of 52% of the simulations, because here's all the simulations. 51.6% of simulations versus 48.1% of simulations versus 3% of 0.3% of simulations, 0.3 because that's 1,000 simulations. So that's a simulation of what happened. And then you go down, they even have the state-by-state breakdown. You have the popular vote right here. And I wish for visualization purposes, Kennedy was not in this graphic because it polls it'd be better to see a better width of the intervals. So if this was a ggplot, I could remove. And there you go right there. This is the win probability, and it's over time. And you can see things are just shifting around left and right. And there you go right there. But that is it. And it's got a whole breakdown. You can click on any state and see what's going on each state and win probabilities. I mean, it's pretty crazy. So really cool site right there. And the reason I bring this up is because of the confidence interval idea. The confidence interval means we are 95% confident the true result will be in that interval. It doesn't mean the true result is. It just means 95% confident that if we were to live in 100 realities of which the results occurred in, 95% of the time the result would occur in the interval. So we don't really, it's kind of odd because you're like, well, how would that work? You can't live in multiple realities. So we have to think, given our reality that we live in, if we're trying to think the true proportion of teenagers who use the internet, well, it's somewhere between 42 to 48% of the time. Kind of, we have a 95% chance of being right. There's a 95% probability the truth is in that interval. Is it in the interval? Well, the only way to know would be to do a census of the population, which we're probably not going to do. So the truth would be for all teenagers, what percent use the internet? Our interval is making an inference about the truth that we're 95% confident that the true proportion of teenagers who use the internet is somewhere between 42 to 48%. And here's the thing to know also. When you're looking at this interval, the interval goes from 42 to 48. So what is the margin of error of the interval? What is the margin of error of the interval? I'll explain how to get margin of error in a second, but people might already know. Not 6. Good guess. Good guess, Noah. Good guess. Margin of error is always the length divided by 2. Yes, DD's got it right there. So when you think of the margin of error, you can write 45 plus or minus 3 because the margin of error is half the length of the interval. A lot of people say 6, and that's why I ask. And when you get to the test, people sometimes write 6, so that's the length, and the margin of error is half the length. Does that make sense? And you can think of a margin of error as a plus or minus. So the margin of error is a plus or minus on the interval. Like 45 plus or minus 3. Like you say to your friend, when do you get here? And they say, 5 p.m. plus or minus 20 minutes. That's the margin of error. The interval length would be 40. So margin of error is half the length of the interval. Now this question simply asks, interpret the interval. I am 95% confident the true proportion of teenagers who are online constantly is contained in the interval 42 to 48%. If you notice, I didn't read their interpretations. Because on test 3, you will have to write interpretations. I am blank percent confident that the true blank is contained in the interval blank to blank. So when you think about this for the 538 example and how this relates to the real world, if we go over to 538 election polls again, and I want to show you just how this is real world knowledge right here. You go to the results right here. Who's ahead? Here we go to the hand. There we go. And then we go down to here. If we go to electoral votes, I am, and there's the Trump one. I am 95% confident Trump will get between about, could be as low as, and I'm saying this right now, that's about that's about 2. Oh man, I wish they put the interval numbers on here because I have to ask. Okay, I'm gonna draw on it. That QR code will be used later today. So, okay, I have to draw to figure this out because they don't give the numbers. Don't give the numbers to me. Okay, so the Trump interval hits right about here. That's about halfway on that one. No, it's a little lower. It's about a third up. There it is. And it goes all the way to right there, which is very easy to estimate. That's about 400 to 1. That's a third, and that's a length of 130. A third of that is 45. This is about 180. You're like, well, yeah, Brian, most people get between every presidency. The thing about intervals, they're usually wide. Intervals are very wide a lot of times. This one goes down to about, that's a fourth of that, so about a distance of a fourth. So a fourth of that is about another 30. So a 30 off that is about 100, almost close to. And then all the way up to, oh, no. I was looking at the bottom of that. It's not the bottom. It's all the way over here now. It's there. That's easy to estimate. That's right under that. That's about 130. It's almost at 135. We'll just put 135. 135. And over here, it hits here-ish. So it's over here. And that's about 2/3 up on a length of 140. So that's about 90 higher. So that's about 359. There we go. And just think, how do you estimate the 108s? Just using the number line. The test would have to give it to you. This is, so I'm just kind of doing like how far up on that interval it is. So don't worry, no test would have you do that. That's, I mean, kind of guesstimate, but it's, yeah, and this is the way to be read. I am 95% confident that Harris will get between 135 to 359 electoral votes. Connor, good to see you here. Happy early Halloween. Connor, I got something cool for you. Connor, if you want, did I already lose it? Hang out for a half second. Because did I paste over it here? Oh, man. Give me a half second, Connor. If you want, Connor, there's going to be some fun at UT today. Not that I'm trying not to, I won't ruin any surprises. But here, where'd I put it? 2 seconds, Connor. Hang out for a half second more. Okay. Anyone here can do this, and I was told to promote this by someone. So, if you want, I was told to promote this by someone. You can, it's the surprises, but I was told to promote this by somebody unrelated to me. Just maybe. They might make a guest appearance in class tomorrow, but I'm so excited to see Connor there. Connor, I've got a new addiction, Connor, and it's not Red Bull. Oh, Connor, I got a new addiction. It's Monster. Monster. So Connor, so good to see you, and I hope you're doing well. Message me on LinkedIn or whatever, but Connor, haven't seen you in a while. Thank you, Connor. So surprises for later. Check it out. I got no idea. I got no idea. Maybe we'll find out. Maybe he'll be around campus later today. Around I heard from him that he'll be around campus. That's the word. He'll be around campus. in the for the cosplay thing. There's like a cosplay event out in the 21st Mortgage area outside of the Student Union. He told me he'd be down there. This is more fun office hours. We just had a test last night, so maybe he'll be there. You don't know. You never know. Possible. Yeah, thank you, Connor. Connor, I'm 99% sure I know which one you are, and Connor knows my love of Red Bull, so I think Connor would be like coconut Red Bull. Yes, and thank you, Connor. I remember you told me about going up the steps. I think like you told me about that when in 2020, when just fun times back in the day. So, but Connor, so good to see you. This is the thing about confidence intervals. They're usually very wide. And so coconut Red Bull, know what I'm talking about. Yeah, and message me. Like, hope you're doing well. We're doing great. Chelsea and I are doing awesome. So really, really having a great time. And I'm back in Knoxville now. And so if you look, these intervals are super wide and they probably will contain the truth because pretty much every electoral college has had these numbers contained within. I am 95% confident the true electoral college votes that Harris will get is contained in the interval 135 to 359. I am 95% confident that the true electoral votes that Donald Trump will get is contained in the interval 180 to 400. That's just the stats. That's no political opinions. That's just the numbers. So this is what we need to be able to do, is we need to be able to turn kind of these problems into why would we do them? Because why are you learning this? It's because people create intervals to estimate truths. So one can be 95% confident that if we were to ask all teenagers, this is like election day when we talk to everybody, that's what it means to think of what the truth is if one talks to everybody and gets all the electoral college answers, then we will know the truth. So P in this example is the true proportion. And we believe with 95% confidence that P is contained in the interval 42 to 48. Explain the meaning of 95% confident. So this is where you get into stats theory. 95% of 95% confidence intervals will contain the truth 95% of the time. As I said, if we lived in a multiverse where we could have different outcomes, 95% of the multiverses would have the truth in the interval. So it's not about the one interval containing the truth, because the interval does or does not contain the truth. On election day, the result will either be inside or not inside that interval. But with 95% confidence, we know that if we keep creating these intervals, 95% of the intervals we can create will contain the truth. It's about the law of large numbers, which we learned in chapter 10, that the repeated trials will approach a true proportion of the intervals containing the truth. So a lot of these topics overlap. So if one collected many random samples, like repeatedly made intervals, about 95% of the confidence intervals constructed would contain the truth. 95% of 95% confidence intervals contain the truth 95% of the time. Sounds like I'm just saying nonsense right there, right? But no, it's a fact that the repeated creation of 95% confidence intervals will lead to 95% of the 95% confidence intervals containing the truth. Of course, you can make 98% confidence intervals, and the repeated creation of 98% confidence intervals will lead to 98% of 98% confidence intervals containing the truth. Oh, I think, Noel, or if Connor's still here, what do we have for this one? When we are doing this right here, and we are building confidence intervals, if we reach out 2 standard deviations, it should say it's about this confident. My guess, if Connor's still here, he would know the exact number. If we reach out 2 standard deviations, think of the empirical rule, would be about how confident. If we reach out 2 standard deviations, would be about how confident. 2 standard deviations would be about how confident. If we reach out 2 standard deviations. What do we got? I feel like 95. You're right. Yes, you got it. There you go. That's it. Connor, do you still remember the exact z-score? So we go right here and we go to the applet if we want exact z-scores. The exact z-score is 1.96, or rather 1.95996. And you don't need to memorize those. 2.3263 is 98. 2.5758 is 99. 2.17 would have to be like a 90. No, don't worry, 1.96 classic, right? No, don't worry, Connor. I'm throwing you some Mubot points. I think you were here before Mubot, Connor. Connor's been around when we used to have huge in-person office hours. We've had pretty good ones this semester, but We used to have like, we'd fill the whole room, people would be crowding in. But if you want to figure out the z-score, you go here to find, so using the p-value, go between, because we're going to use the p-value, and there it is, 1.96 or 1.95996, and there it is right there. I just think it's interesting because it kind of turns into I don't know, the 996 is cool. I don't know it after that. I don't know. Maybe today I'll remember 398. Sure, I'll try to put that in my head. But then if you want a 98%, which is 2.5758, it'll round up though, or 99% is 2.5758. And then 98% is 2.3263. There's that. 90% is 1.64495, I believe, but it's going to round to 1.645. 449, there it is. So it's 1.645. 449. I think I said that the first time. 80% is 1.2817. How's that last one round? Oh, it is 16. Dang it. 1.2816. And 50% is 0.6726. I'm not sure on those last decimals. 0.6745. 45. Gotta put that 45 in my head. Do you need to memorize all these? No. Here's the things you should know. As you get more confident, the z-score gets wetter. So Noel, anybody? As you get more confident, the z-score gets wetter. More confident, the z-score gets wetter. As you get more confident, the z-score gets wetter. Because you're covering more area on the curve. These are things you should know. Because the applet can get to the answer, or you can ask your phone. What is the z-score for an 80% confidence interval? Oh, brought up a table. So as you get more confident, the z-score gets bigger and bigger and bigger and bigger because we're covering more of the possibilities of what it could be. You're more confident because you cover more values. Your friend says to you, give me a 10% confidence on what dinner will cost tonight. You say between $40 to $42. They say be 90% confident. You say between, I don't know, $20 to $60. Be 99% confident, between $2 to $100. Notice as you get more confident, it gets wider. Now, technically, we would do it around the center so that it would be symmetric around the center each time. And so more confident means wider, and this is controlled by the z-score of the confidence interval. And you can remember 68 is basically 1. And you can see right there, we'll round it down so it actually rounds nice and neat. 95 is basically 2, and 99.7 is basically 3. If you want the exact z-scores, then what you do is you go to the applet and you put in 98% and you round to like 2 or 3 decimals, not negative decimals, 2 or 3 decimals, depending on how you want to round your problem. And the applet can get you exact answers. So a 95% confidence interval is basically 2 standard deviation. 99.7 is basically 3. There you go, empirical rule. This one just jumps into the problem right here. Chapter 13. Chapter 13. Homework question 2. And this is z-scores. Okay, so we keep saying it every day.
Notation.
It's all about that notation. And don't worry if you got it wrong, but there were people who missed some of the notation, like what is p hat? It's the sample proportion. And I beg this of you, learn the notation. Learn the notation. Learn the notation. So when you look at this problem right here, it's all about the notation. You go right here and you say, we have this many voters. That's the sample size. The poll had a sample size of this. The percent who said we are on the wrong track was this from the poll. So that's a sample proportion. And the complement of that is going to be this. And it wants the margin of error using a 90% confidence. So that's not the z-score, but that's going to be related to the z-score. As we said earlier, you have to go to the applet to get the z-score, or you have to memorize it. The z-score for 90% confidence is 1.645. You can add on the 5 right there if you want, 1.645. So the z-score relative to this is equal to 1.645, and we'd give that to you on a test. We don't expect you to memorize them, and you won't have access to the applets. So you just need to know concepts that when you are more confident, you have a bigger z-score because you cover more area on the normal curve. So now we have to write the equation because we can solve for the margin of error rather quickly. P hat plus or minus z star square root p hat q hat over n square root. And the margin of error is this quantity right here, and I forgot my plus or minus. Plus or minus, because the margin of error is plus or minus. And all we do is now plug in the values to get the margin of error. Well, the margin of error is going to be 0.746 times 0.254, which are complements, over 1997 square root. And then we have to times by 1.645. There we go. That's got it. So we have now written the equation. To solve it, we go 0.746 times 0.254. There's the top. Divide by 1997. Good year right there. This is a decimal of 0.000094884. Just remember to count that. We're going to square root it because that's the next step. Square root it. And now we times by, we're right here. We've solved everything in here. Times by 1.645. And there we go. There's the margin of error. That's got it. That is the margin of error. Where is it? It's over here. Margin of error, 3 decimal places. Check answer. Good. That's it. So now when we look at this right here, it does their interpretations, but I ask you to always do your own interpretations. I'm going to round it to about 2%. And I don't love the way they do theirs, but I would say I am 95% or 90% confident that the true proportion of voters who think that the country's on the wrong track is contained in the interval 72 to 76%. Now, I did some nice rounding right there. What you need to do, here's the margin of error. It's 1.6. So it'd be 74.6 plus or minus 1.6. So that would be 73 to 76.2. There we go. So I am 90% confident that the true proportion of voters who think that the country's on the wrong track is contained in the interval 73% to 76.2%. I can't state this enough that this is a test 3 question. Knowing how to write your interpretation with the I am blank percent confident that the true blank is contained in the interval blank to blank. One is 90% confident that the observed proportion, yeah, within, I don't like the way I did this. Because we're not making inferences about how close it is to the sample because we know what the sample is. It would be 0 away from the sample because the sample, we're saying the observed, which is the sample. The observed is what you see in your sample, and so it can't be away from the sample. We're trying to figure out how far away it is from the truth. Don't love that interpretation. Compute the 95% confidence interval right here. So the same sort of math will be done right here. Once again, this really boils down to, notation brother. So for this problem right here, let me mark it also in the notes. There's the problem. Oh, I didn't mark that last one. Got to take a guesstimate at a time. We did that last one quickly. Chapter 13, homework. Probably going to do these more. So confidence intervals. And 38, 53. Chapter 13. Noel, are you still here? What are your thoughts? Let me know. So can you identify, if you're here, can you identify any of this notation? Can you identify any of this notation? Because on the test, if you identify the notation, then you start putting it into the formula, and it wants the upper and the lower for a confidence interval. So being able to identify the notation is going to be key for the test. And if we're doing a confidence interval for the percent we're doing, poll conducted said they are considering moving out of state. So this is the proportion of people who plan to move out of California. We want to know the true proportion of people who plan to move out of California. So when you look at this right here, identifying the notation goes the following way. We have the sample size of individuals we spoke to. We have the proportion who responded that they plan to move out of state. Now we do Q hat equals 1 minus P hat, and it would equal to 47.8%. And that's because it's 1 minus 0.522. So that is the, or you might be responding. I might just have the text up. No. Oh, there you are. No, you've been here this whole time. Noel, I clicked a button. Thank you, Noel. Let me throw you some more points. Noel, great job right there. I clicked a button Why is, and sorry, you were saying it, and also Connor was saying it. I had clicked it. I'm still recovering. It's good to hear back in Texas. Tell back from yes. Reach out over LinkedIn. Yeah, awesome. Tell Sean Van Tull I said hi if you ever see him around. I should know who that is. Sorry, Connor, and sorry, Noel. I clicked on something. I was like, no one's talking. Maybe it's my fault. It was my fault. So, Noel, do these metrics make sense? And so, more confident does not mean more accurate. I think I might be able to actually do that. Let me try that, DD. Let me try that. Let's see if that works, if it just gives Noel points. So it might actually do it. I don't usually use the commands that way, but we'll see if it actually works. So let's see if it works. No, MeBot's mad. Well, yeah, you're supposed to be able to do plus username. Let's see if he does it. Okay, it's time for the interval. And it says make a 90%. Go to your applet right here. And on the applet, you need to find the z-score. So the z-score for a 90% confidence interval is 1.645. It'll always be that. This is the equation right here, Noel. P hat, which is the sample proportion, plus or minus the z-score relative to how confident we are. That's what the star indicates. So it's relative to how confident you are, times the standard error. This is the standard error of p hat. So you could just write, literally, you could just do standard error p hat. But the standard error of p hat is equal to the formula p hat times q hat over n square root. Very much like p times q over n square root. P times q over n square root. Now it's p hat times q hat over n square root. So we are just going to plug in the numbers here. So yes. I was like, what? No squeak today. There we go. Now we just solve out the whole thing. Solve this inner part first right here. 0.478 times 0.522, divide by 4527, square root. So make sure this times this over this, square root of the quantity. This is now the standard error, so that is the standard error. Like that, what is inside there is called the standard error of p hat. Take this quantity times by 1.645. You now have the margin of error is 1.22%, and it does want it as a percent, so I'm going to times this by 100. So 1.22%. So this is 1.22% plus or minus 52.2%. So when you subtract from this, you're going to get 50.98, comma 53.42. I like doing it in my head and then I make errors. Does that make sense, Noel? Any of these steps, everything over here is called the margin of error, the plus or minus. And this is called the center of the interval. That is the center of the interval. So the interval is centered at 52.2. So I can do the equation to calculate what you do with the plus or minus in the equation. So for the calculation right here, you go 0.478 times 0.522, divide by 4527, and then square root. And so you get this quantity right here. So now I'm just going to multiply by this right here, times 1.645. And then we get this quantity. Now, then what I did right here is I times it by 100 because it's asking by percentages. So that's not as a decimal anymore, but a percent. So I did then multiply both by 100 when I went down to these steps, like 52.2 proportion-wise is 52.2%. So 50.98. Oh, and once it rounded, and that was 52. I'm doing it by memory. Oh no! It was, let me look at it again. Watch me make an error. 50.98. Oh, why am I not? 50.98 is right. 50.98 and then 53.4. There we go. That should be right. Good job. How did you mental math that? I don't know. My brain's breaking. I like mental math. Mental math is fun stuff. I am 95% confident, or 90% confident the true proportion of Californians who consider moving out of state is contained in the interval 51 to 53.4. It's our good answer. There we go. Since the confidence roll, it's saying does not contain 50%, so it's greater than 50%, we would not believe it. So the government is considering investing in a new affordable housing if they can be reasonably sure it's more than 50%. Yeah, so we're pretty sure it's more than 50% want to move out of state. And let me see here. They should invest because we're reasonably sure that it's higher. So they're going to make that decision if they're reasonably sure it can be higher. Let me go look at it again. So you did not have to put another 0.522 in the blue box. Down here at the bottom, this is the final calculation here at the bottom. So this no longer goes with everything up there. So this is not a blue box down here or a yellow box. This is where you do the plus or minus, and I'll show this because maybe I should have, like Didi said, I shouldn't have mental mathed it. You go 52.2 minus 1.22. I can't even do, see, I can't type things in. That's why I mental math it. 52.2 minus 1.22, and there you get that number. 52.2 plus 1.22, and you get that number. So this is where you do 52.2 minus, you get this number. 52.2 plus, you get this number. A confidence roll always ends with an upper or a lower and an upper value. And I'm going to go grab a quick drink and protein bar for today because I'm going to need it. So we'll do more really good office hours. Noel, Didi, Connor, until next time. Bye for now. I need some snacks.